one. All right, so for 5, 5, I want you guys to be honest when you are reflecting, because if you're not feeling very confident in that, then that tells you need to work on G12 and G13 during the warm-up. Today's lesson, we are going to be learning about solving a one-step equation using something called the multiplicative inverse. So go ahead and shade in to see it there. And stay on this page because I want to review what a one-step equation is. So go ahead and copy this down. X plus 14 equals 33. We learned way back in chapter 3 how to balance a one-step equation. Our goal is to get x by itself. So what's the opposite of adding 14? Taking it away, right? So we're going to subtract 14. And we have to remember that we have to subtract the 14 from both sides. So whatever you do to one side, you have to do to the other. Yep, you've got to do it to both sides. So we get x is equal to, let's see, 23, 19. X is equal to 19 for that one. You could also have a fraction that says negative 3 is or negative 3x is equal to 21. This would also be a one-step equation. And what is technically between the negative 3 and the x? Multiplication. So what's the opposite of multiplying? Dividing. So we want to divide both sides by negative 3 this time. And we get x is equal to negative 7. Yep, it would be a negative 7. So today, we're going to be balancing one-step equations just like that, except we're going to be balancing one-step equations that involve fractions. So at the beginning of the year, we just did whole numbers. We're going to do a little bit of review and spend some time with fractions. So go ahead and turn to your 5, 6 notes. And you can decode our first vocabulary word, which is multiplicative inverse. It is a mouthful. It's a lot to decode too, because it's multiplicative. Nope, that was multiplication. This is multiplicative, and then inverse. And we're going to practice saying that as well. So our first vocabulary word for today is multiplicative inverse. What's the word? Very good. All right, so a multiplicative inverse is actually just a reciprocal. What's a reciprocal again? When you flip the numerator and the denominator, right? So a multiplicative inverse is a type of reciprocal used to balance equations. So it's a reciprocal that we have to use to balance equations. Go ahead and write 2/3 times x is equal to 12. What did we just talk about? What math operation is between the 2/3 and the x? Multiplication. So what's the opposite of multiplying by 2/3? Dividing. So we're going to divide both sides by 2/3. Well, when we're dividing by fractions, so here we would have 2/3 divided by 2/3. When we're dividing fractions, what did we just learn we have to do? Keep, change, flip, right? So we would have 2/3 times by 3/2. So do you see how I use the reciprocal there? What's going to happen? It's just going to be 1. 3 divided by 3 is 1. 3 divided by 3 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. So we just simply, that all cancels, and the only thing left on the left side is x. And then on the right side, again, I have 12 divided by 2/3. So if I write that off to the side, I have 12 divided by 2/3. So I'm going to keep, change, flip. What can you cross cancel? 2 and the 12. So we get a 1 and a 6. And what's 6 times 3? 18. So you get 18 for your final answer there. Now, it's actually not even going to be that much work every time. So, what we did was we initially wrote it as a division problem. And then we proved that with division, you just multiply by the reciprocal, right? So instead of doing the division, we're just going to skip that step. And we're just going to instantly multiply by the reciprocal. This is what we're going to end up doing on the next page. The multiplicative inverse property tells us that the product, what does the word product mean? Tells you to multiply. So the product, it's the answer to a multiplication problem. You're right. Yep. The product of a number, so this is my number, 2/5, and its multiplicative inverse, 5/2, is always going to be 1. So anytime you multiply a number by its reciprocal, the result will always be 1. In my numerator, what's 2 times 5 give you? 10. And in your denominator, what's 5 times 2? What's 10 divided by 10? It's just 1. So anytime you multiply a number by its reciprocal, it will always be 1. Or you could have done some cross canceling. Either way would be fine. So flip to this next page, and we're going to do 2 examples together where we are using a one-step equation to solve. You okay? Yeah? All right. So your goal, anytime you're solving equations, is to solve for the variable. So I'm going to write that above. If I am trying to solve a one-step equation, I just am simply trying to solve for the variable. In this example, what side is my variable on, the left or the right? The left, right? So I have to get rid of that 6/7. So I want to get rid of that fraction because I want it to just say x. I don't want it to say 6/7 x. I want it just to say x. So what I'm going to do is actually multiply by the reciprocal of 6/7. What's the reciprocal of 6/7? 7 over 6. So I'm multiplying by the reciprocal. Well, my 6's cross cancel, right? My 7's cross cancel. So the only thing left, you see how I just got x completely alone? That was my goal. It's not equal to 21 because, ready, what you do to one side, you have to do to the other. Good. We need to multiply this side over here by 7/6 as well. Can you cross cancel anything here? 21 and 6 can both be divided by 3. So 21 divided by 3 is 7. 6 divided by 3 is 2. Yep. So then you get 49/2. And who can raise their hand and finish it for me? That's my improper fraction. I want to mix numbers. And 2 goes into 49 a lot of times, just to give you a heads up. Oop, raise your hand, raise your hand. Very good. 24.5 is equal to x. And the reason that we use that multiplicative inverse is because it cancels things so nicely on the left side that x is by itself instantly. So really the only work that comes along with it is multiplying over here. Now on this one right here, what side do you see your variable is on? This time it's on the right side, all right? We're still going to go about solving it the same, but this time we have to look at the right side because that is the side with my variable. I want to get rid of that negative 3/11. So what's the reciprocal of negative 3/11? Yep, you could write negative 11 over 3. You could write 11 over negative 3. I like to keep my negative in my numerator. So I'm going to multiply by negative 11 thirds, just flipping that fraction. What happens to my 3's? They cancel and become 1s. I'm just going to cross them off. What happens to my 11's? Cancel and become 1s. Yep. Well, hold on. I still have a negative times a negative. What do I get when I multiply a negative times a negative? A positive. So you see how those two cancel and become positive? Now I've got an x completely by itself because I've canceled everything over here. But you have to remember what you do to one side, you have to do to the other. So we're going to multiply this side by negative 11 thirds. You guys see any cross canceling? Well, the 11 and the 55 can't cross cancel because they're both in the numerator. Yep. 3 doesn't go into 55. All right, so we're just multiplying here. We can't cross cancel. It is perfectly fine to use your calculator to multiply negative 11 times 55. Oh, come on. Negative 605. Negative 605. And then in my denominator, I still have that 3. Now, who can raise their hand? I do not know how many times 3 goes into 605, but who can raise their hand and tell me what do I type on my calculator to help me figure that out? Because with these big numbers, you might need some assistance getting that whole number. So what would I want to type in? Good. If you type in 605 divided by 3, our whole number is 201. That's a really big number, isn't it? What that means is 3 goes into 605 201 times. Yep, you're exactly right. Now I have to multiply 3 by 201. And we see how close we are. We're at 603, so how many are left? 2 left over. What am I forgetting? The negative. Yep, we had this negative that we were kind of ignoring, but we're going to add it on now. Yeah, go ahead. No, the negative goes with the whole number. You put the negative in front of the entire fraction. Yep, messed up. Thank you. All right, your homework tonight does not need to get uploaded to Google Classroom, just so you know. I want you guys to do questions 1, 2, 3, 4. 1, 2, 3, 4. That's all you have to do. 1, 2, 3, and 4.